Can you hear me now?
Oh,
Yes.
perfect. Yes. Woohoo.
Excellent.
Perfect. Hey, you know what? If we push enough
Nigel.
buttons, then something will happen. Right? All right, Nigel.
Awesome.
Take it away. Let's talk about GraphQL and .NET Core.
Excellent. So, welcome everybody. I'd like to basically talk about GraphQL and sort of an introduction of it in .NET Core. Most of the talks I've seen around the internet mostly focus on this around sort of the Node ecosystem, and I thought it'd be good to talk about it from a sort of a .NET perspective. So, what are we going to talk about today? We're going to talk about sort of the basics of GraphQL in terms of introduction to why we want to use it and how it kind of works. And then we'll talk about how to sort of build it within a .NET Core ecosystem and using sort of the hot chocolate GraphQL library. So let's get into it. My name is Nigel Sampson. I work at a company called Pushbay here in New Zealand, and we're using GraphQL across a number of our microservices and applications. My GitHub handle and Twitter handle there, so if I don't get a chance to answer your questions later on, hit me up on Twitter. So what is GraphQL? It's a specification originally written by Facebook for querying data from a service.
Hey, Nigel, really quick, can you close the little box for Skype on the upper right-hand side?
Sure, done. Excellent. So as I said, it's a specification for querying data from the service. Facebook originally wrote this internally and then shared it as an open source. They also shared an implementation in JavaScript of that specification. And since then, it's been picked up by the open source community, and there's a number of libraries, almost every language, that support GraphQL. In .NET, we've got probably two major libraries you're likely to see. One is Hot Chocolate, and the other one is one called GraphQL.NET. So what's really interesting about GraphQL is that it supports, as I said, a strongly typed schema with a queryable API. So this means that you can actually look at the schema of a service. You're going to know what data you're going to get back from it, what fields it has, and what sort of types you expect from it. And the GraphQL server actually enforces that type specification. So you're not going to have a problem where the spec or the docs say one thing and the service actually returns something else. In terms of databases or storage, GraphQL spec has absolutely nothing to do with it. You can store your data in anything, whether it's a database, a graph database, relational database, flat files, or even hard-coded, or even delegate them out to REST calls in other ways. So let's get into it, some actual demos. So the tool I've got in front of me here is one called Insomnia. What this is basically a normal sort of request tool, much like Postman, where you can use it to send requests to a server. I'm using it because it's got some excellent GraphQL support. So for this scenario, we're going to talk about this idea of a blog. Most of us sort of understand the domain model of a blog in terms of posts, authors, comments, images, etc. So for our normal front page scenario, we're going to want to get the collection of posts. We're going to get the date, the title, the author. Important thing is we don't want things like, say, the HTML content of that post for the front page scenario. So on the left here is the GraphQL query. So this is what we end up posting to our server. You'll notice up here we're actually just sending this to a single endpoint to /GraphQL. And we post this query, and on the back here, on the right-hand side, is the results we get. So as you can see at the top, we're marking this as a query, and we're going to query from the posts field on top of the posts endpoint, and that's going to return a collection of posts. And from each post, we're going to ask for the ID, the title, some other fields, the image, and the URL for that image, the author, and their name. And so you notice on the right-hand side here, the data that we get back is in the same shape or structure as the fields on the left. So we can send this, we get back the data nice and easily. What's really important here is that we're deliberately querying for the fields we want. The specification for GraphQL has no way to say, get me all the fields or the equivalent of select star. And that's really important from a usage point of view. And we'll get into reasons why in a minute. So another scenario, but a slightly more advanced query, the user's clicked on a post and we want to actually get the details for that post and show it in a page. So again, it's a query and we're querying from the post field now rather than posts. And this post takes an argument called ID. And what we're doing here is called a variable. So up the top here, we've declared a post ID variable of type ID. And here we're using that variable to select the post. We're asking for the title, author, and name again, but this time we're asking for the HTML and the comments on that post. Down here in the bottom of Insomnia is where we're actually providing the value for that variable for post ID. So why we want to use this idea of variables is that what that means is that query up the top here can be static. It won't change in terms of usage. We can have this query then stored in some sort of resource, document, file, whatever, that becomes constant. And it's only the variables that need to change. This means we're not trying to build up our query via strings or anything like that, which could be susceptible to some sort of injection problem. Again, on an image this time, we're actually providing an argument for the size, and we can go from here. Comments, we're getting back a list of comments, and here we can see the data on the right returns the shape of the data on the left, which is excellent. So why, from a sort of introductory point of view, GraphQL, why is any of this a good thing? Well, from an application point of view, we're only ever getting back the data that we care about for any given scenario. We're not getting extra data, and we're able to get all the data we care about within a single request. So most times when people talk about GraphQL and the problem it solves, they talk about it in this idea of under selection and over selection. If we imagine a post like this, trying to do this via a sort of a very denormalized REST request, we might end up doing a number of requests, one to get the post content, one to get the comments on the post, one to get the details of the author of the post, etc. This is this idea of sort of under selection, that a single request can't get us all the data we care about, so we have to issue multiple requests to multiple resources to get our data. Conversely, in the first scenario, if we were getting all the posts, and that posts endpoint in a normal REST request was actually returning the HTML, which I was promptly discarding, this is this idea of over selection, that I'm getting more data back on the response than I actually care about for my scenario. Now, that may not seem like much, but when you're building things like mobile applications, this means you're consuming bandwidth, you're consuming someone's data cap or battery life, but doing a lot more work on the wire than you need to. So this is one of the sort of main benefits in terms of applications. This is being able to get all the data you need for a given scenario in a single request, and making sure you only put the data on the wire that you really care about for your application. From an operability point of view, this is also really good. This idea that you don't have this notion of select star means that applications are only ever going to query for the data they care about. And let's say we wanted to remove a field off a post, for instance. We could mark it as deprecated, put out an API notice to say, hey, we want to remove this field. And you can actually monitor via your logs which applications, which queries are still querying for that field. And you can make a considered effort to migrate those applications across to using a different field or whatever you're doing for your migration strategy here. And then again, once you've got no logs of people using that field, you can kind of remove it safely, knowing that you're not going to cause breaking changes within the application. So as I said before, GraphQL is a strongly typed system. And so most GraphQL implementations have a way for you to pull the schema in some way. So this is called the SDL, or the Schema Definition Language. It's part of the Facebook GraphQL spec. We'll go into some detail about it in a moment, but this is essentially the more human-readable version of the schema. We can see here types, authors, comments, etc. We'll go into some more detail in a minute. The second really interesting thing is all GraphQL endpoints implement an introspection schema. So this lets me actually inspect the schema itself. I can say, give me all the, in this query, it's giving me all the types, the name of that type, the fields on that type, and their names. And so if we go down here, we can see things like post has an author and comments and HTML and so on. And this is essentially a really good way for software tools to get access to that schema, and they can do all sorts of number of things with it. One use case is generating TypeScript. So TypeScript can use these introspection schemas to essentially generate strongly typed types on your client side. And tools like Insomnia here provide IntelliSense over things. And what it's doing under the covers essentially is that Insomnia is using this introspection API, making a request to your GraphQL schema to pull back all the information it needs in order to be able to provide IntelliSense. And last but not least, we have mutations. So mutations are a way for you to modify state via GraphQL. They're clearly marked at the top as being a mutation, being different than a query. And ultimately, though, the only thing that is actually the mutation is that top level thing. In this case, it's submit post. The rest of this query essentially is a query on the result of that submit post, which is obviously the post itself. Again, we're using a variable here, in this case, a complex variable of type submit post input. And I've got the properties for that input down here, and ultimately the result of that mutation on this side. Cool. There is a third thing. So we talked about queries and mutations just now, but there is subscriptions, but it's probably out of the scope of a 25-minute 101 talk. So a GraphQL schema, as I've said, has a strongly typed schema like this. The other thing it also consists of is a resolver. So the resolver is what happens when each of these fields is queried. So when you're implementing a GraphQL service, you're basically declaring a schema and attaching resolvers to that schema. But first, let's take just a bit more of an in-depth dive into what the schema looks like. So here you can see we've got things like types, really simple types like author, and these are just sort of what we call object types. All types have fields. These fields can be of type scalars. So scalars are things like ID, string, Boolean, and the like, or they can be more complex objects. So if we look at something like a post, it has an author, which references back to the author type. You can also, if you want, create your own custom scalars if needs be. We have enum support as well. You notice there's a lot of exclamation marks through the schema. So what that is that most GraphQL, now the GraphQL spec has the notion of nullability. So if we have an exclamation mark here, it means that this property cannot be null. So an author must always have an ID. It must also always have a name. If it's no exclamation mark, it means that it may not. So it might be null. In this case, our post has a null HTML. It might not have HTML at the moment. We also have this notion of lists. So in here we have if we go here, take a look at this one, post of comments, and the square brackets indicate that this is a list. So post obviously has a list of comments, and it kind of gets a bit confusing with these double exclamation marks. What this essentially means is that the comments field on the post can't be null, and the values within that list can't be null. So it's a non-null list of comments, or sorry, a non-null list of non-null comments, which is a little confusing, but it doesn't matter too much. Excuse me, sorry. And the last thing is the input type. So the input type is essentially the complex types that we're going to be posting to our mutations or posting to more complex queries. And they're defined separately than sort of your regular types because they've got slightly more restrictive rules on what you can do with them. And last but not least, we have a sort of a schema declaration. And this defines our top-level query and our top-level mutation. Right, so let's jump in to see how we can build some of this stuff. So I've got a normal sort of .NET Core web, a blank web app that I've kind of added a lot to. So we're going to be calling using EF Core and talking to a local Postgres database, running out of Docker for our data. But ultimately, the data source, as I hope you'll see, is kind of irrelevant for this. So, what I've done is referenced Hot Chocolate ASP.NET Core, and then obviously a few other libraries for some fake data, some markdown rendering, and again, EF Core in order to talk to Postgres. So that's all we're going to need to reference. And the first thing we're going to do is set up our endpoints. So in our configuration, we're going to create two different endpoints here. The first, using GraphQL HTTP post, is setting up the actual service itself where we're going to post our queries to. I've just got that out/GraphQL. And I've got this here, use graph HTML get schema, which is essentially setting up a second endpoint where I can get do a request to get that STL, which is this thing here. So I want to set that up because I think it's quite easy, quite good for developers to call that and look at their schema. Right, so that's all the setup we need. Now we need to kind of start defining our schema and our resolvers. So let's take a look at a really simple one first. What you're going to see is a pretty common pattern of things like a type, in this case, author. So this is my EF core model with obviously an ID and a name. And we're going to see a matching type here. So we've got an author class up here, and we're going to see an author type down here. So this is how we're using code to define the author type within the GraphQL schema. Jumping back a bit, there's actually two ways we can define the schema in GraphQL. The first is what's called schema first. And if you watch a lot of .NET sort of Node ecosystem GraphQL talks, they often do what's called schema first. So this is where you define your schema using the SDL. Define it basically as one big string. That's your schema, and then you bind resolvers to that, which we'll get into in a minute. What this works, and it's actually really good for demos, but it gets pretty unwieldy as the schema gets larger and larger. And so one of the other approaches you can do is code first. So code first is what we're kind of showing here. This is using C# to define the schema of our GraphQL library. You can mix and match the approaches, but you tend to find you go sort of all in on one or the other. One of the other benefits for me in terms of code first is it means that some of these types can be shared between different microservices in different ways, especially when we get down to sort of custom scalars. Right, so we've got this author and author type here. So again, author is my normal EF DTO or entity, and author type is the declaration or definition of that author within our schema. Now, Hot Chocolate's got some real good capabilities around this idea of sort of inferring the schema. So if I didn't do anything and I didn't create this class at all, Hot Chocolate could still infer a lot. It would probably still be able to infer that there'd be a type called author. It's going to have a property called ID and a property called name. But what it might get not quite right for me is in my schema, I want the type of the ID to be ID, not int, and I want the string to be non-nullable. So this is why I've created this author type here, and I've defined for the field ID, it's a non-null type of ID type. And again, you'll see the sort of type suffix happening here. And for the field name, it's a non-null type of string. So this lambda is actually really important. It's doing two things right now. One is it's telling Hot Chocolate what the name of this field is. It's inferring it from this expression, ID and name respectively. And the second thing is this is actually what the resolver. So this is the bit of code that gets executed when this field is requested. So when someone asks for the author ID, it's this lambda that gets executed, which pulls from the ID property on the author and returns that integer or string in the case of name. So let's move on to a pretty bit more complex scenario. So let's look at the top level query. We're actually getting our post and posts from the database. So here we've got a query class. It's got two methods, get posts and get post. And you'll see it's basically just using the DB context to pull from that data. What's interesting is more of the arguments to this. So we're actually doing what's called a service level or a method level injection to the method for the DB context. And I've marked this up with an attribute from Hot Chocolate to basically say this is a service. I want you to inject this using dependency injection. The reason I'm injecting this at the method level rather than the constructor level is because DB context is a sort of a scoped dependency. I want a new one per request. So that's why I don't want to do constructor level injection at this point. If I had some sort of singleton dependencies, then I might declare them as constructors. But in this case, I want them to be scope dependencies, so I'm going to inject them at the method level. You'll also notice for the get post that we have an ID, and it's automatically going to be injected from that argument on that field back over here. This value will automatically be injected into that method call for us. So again, because we have our query class, we have our query type describing this within the schema. Again, we have get posts. So this is saying this is the method to call when this field is called. And Hot Chocolate's smart enough to remove the get and turn get posts into just posts. And again, this, as we said, this is a non-null list of non-null posts. And again, for get post, we're saying that there's going to be an argument called ID, and it's a non-null ID. So we're just doing a bit more of sort of tweaking that inference that Hot Chocolate can do. So this has been all pretty standard stuff. We're basically just sort of mapping things that already exist and tweaking them on the way through. Let's look at a more interesting example. So we have our post type. And we're going to be doing a number of extra things to this. Again, so we're doing some extra things. I've got a helper method here to tweak some of that syntax to get rid of the non-null ID stuff, but ultimately this is the same thing. I'm tweaking nullability for ID and name. I don't want the author ID that's on a post to be in my GraphQL. I want an actual fully strongly typed author. So I've told, in this case, for author ID, ignore it. Don't put it in the schema. And this is the really interesting one here, it's HTML. So on my post in my database, I don't store the HTML. I'm storing the sort of edited markdown, but I want to return the HTML as part of my schema. So I'm creating a new field here, a new field that exists in the schema but not in the database, called HTML. It's a string, and I'm attaching a resolver to it. So this is what I want to call when someone requests the HTML, and it's simply taking the parent post, getting the markdown, and converting it to HTML. So now we have this sort of being computed on the fly and only when requested. And we're repeating this pattern for another number of things as well. So here, we're adding a resolve comments. So call resolve comments. We're going to name it comments, and it's going to return a list of comments. If we go down here, again, we have a method. We're doing service level injection to inject the DB context. We're going to ask for the parent post at the same time. So Hot Chocolate's going to inject both of those. And I can go to the database and retrieve the comments. So this is where I'm sort of attaching more complex types to my my post, and I'm getting some good sort of strong structure to a lot of my GraphQL. This more complex scenario here for resolve author is using a data loader. I don't want to get into too much of the implementation of this right now. It's probably a bit much for a half-hour talk, but ultimately using data loaders is a way to prevent sort of N+1 problems within GraphQL. So if you have this idea that I'm doing a query that's going to pull multiple posts from the database, and those posts are asking for author, I don't want to have 101 calls to the database to get 100 authors out. So a data loader is a way to solve this, but sort of the implementation of this, I don't think really we've got time for. After that, let's quickly look at mutations. They're pretty much the same thing. We have our method here called submit post, again taking a DB context, and that strongly typed that input we've defined. In this case, it's submit post input. So it's just what we want, an author ID, some title and markdown. And we're creating a new post, saving it to the database and returning it. Up here you can see I need a clock from noda time, and so this is where I'm doing my constructor level injection of that. So this is a sort of a common pattern you'll see things like mutation, mutation type, post, post type. This code first sort of approach, code first approach in order to define our schema. From there, we just need to register it. So going back to our startup code, we're doing our work here. So we're doing a couple of things. We're calling the add data loader registry, which we don't need to go into right now. But ultimately, the important part here is add GraphQL. We're using a schema builder, and we're registering that query type and the mutation type we've defined as the top level queries and mutations. And I've got a custom scalar here, which we can probably have a little bit of time to go into, which is essentially a new class to represent offset date times at a noda time. And it's a way to it's using extended ISO to render them down as strings. But this means we can have sort of the idea of a strongly typed offset date time within our schema. Going back to our startup, you'll notice here we're not registering things like the post type or the author type. And we get that basically by the fact that query type talks about posts. And post type, if we go back to that, talks about comments and authors and lists and images. So we don't need to go through and be meticulous about making sure we've registered everything, because ultimately, as long as everything is reachable through the other types, then we only need to register those two level things. Once we've done that, we create our schema and give it back to GraphQL, and we're done. So we have this notion of a schema we've defined using C#, and we have this idea that we're attaching resolvers or methods to each one of these fields to call. Now, some of these resolvers are complex. They're going to databases to do work or to file systems or whatever. And a lot of these resolvers can be pretty small, right? A lot of them are just going to properties to get values, or they're doing some sort of in-memory computation for computed fields. And in fact, if you try and start up a service in Hot Chocolate where a field doesn't have a resolver, this would be an error. Every field needs to have a resolver, essentially, to know what happens when it's called. So that's it. We've now got a sort of out-of-the-box EF core to Postgres database happening. We've got GraphQL served over top of that in a pretty strongly typed way, taking mutations as well as doing queries. So jumping back, I just want to give you a couple of links. The first is for Hot Chocolate itself. It's a great library. I'd highly recommend going and check it out. And the second is the GitHub repo that will contain all the source code from this talk. So there's a bit more in it than I've gone over today. So have a play around, have a look in, see what you like. As I said, I'll be around on Twitter for questions, but I think we've got some time now as well. I can. So the constructor injection, well, actually all of it's provided by Hot Chocolate, but the notion of sort of attributing a service, the resolver level injection with service like this is a thing from Hot Chocolate itself. The reason why you want to do this, as I said, is because of scope dependencies, but ultimately it's Hot Chocolate that's using the DI container to construct or to sort of create these classes for you. And ultimately, it's the thing that's going to be responsible for working out where these injection points come from and so on.